Hello students, this is the third video on applications of derivatives. Okay. In the second video, you have seen some examples. I am continuing the examples. The sides of an equilateral triangle are increasing at the rate of 2 centimeters per second. There is an equilateral triangle. Equilateral means all the sides are equal. Let x be the length of each side. Okay, and this triangle is increasing at the rate of, it is flexible, it is increasing at the rate of 2 centimeters per second, means the edges are increasing 2 centimeters per second. How fast is the area of the triangle increasing when the side is 15 centimeters? Already we have considered a 15 centimeter equilateral triangle and it is stretched at the rate of 2 centimeters per second. Okay. Now, first I write the given things. Let A be the area of an equilateral triangle and X be the side of each edge of the equilateral triangle. And they have given the edge is increasing at the rate of 2 centimeters per second. What we have to find? We have to find at what rate is the area increasing. Once when we had started stretching it, when it has the length of each edge is 15 centimeters. Now, I make use of the formula for area of equilateral triangle. Half base into height we write. Suppose this is the base and it is x centimeters and this will be x by 2. If I want this one, you will find out half base into height. The formula is given by root 3 by 4 into x square. For only equilateral triangle it is. Now, differentiating with respect to t, I get dA by dt is root 3 by 4 is a constant. Derivative of x square is 2x into dx upon dt. 2 as it is, x, the length of the side of an equilateral triangle is 15 centimeters and the sides are increasing at the rate of 2 centimeters per second, they told. Okay, we'll substitute and I simplify, we'll get 15 root 3. Since it is dA by dt, I will write the unit as square centimeters per second. I hope you have understood. Now, I consider next example. A drop of oil spreads on water in the circular form at the rate of 36 square centimeters per second. Find the rate at which the radius increasing when the area is 49 square centimeters. Okay, the drop of oil means first when I take the drop of it, it is in the circular shape and it has some radius. Okay, and once it is spilt on the ground or spilt on water, it is increasing its area. At what rate is its area increasing? Okay, at what rate is its radius increasing? When the radius is 49 pi square centimeters, they told. Okay, let R be the radius of the oil drop and A be the circular patch obtained from that oil drop. What they have given? They have given at what rate is the area of that circular patch is increasing. So I take dA by dt is 36 square centimeters per second. Okay, what we have to find out? At what rate is its radius increasing? When the area is 49 pi, it has some area, what is 49 pi, and it is increasing. Already we know at what rate is its area increasing. We have to find out at what rate is its radius increasing. That is dr by dt we have to find out. Okay, I make use of the formula for area of circle. It is A is equal to pi r square. Then pi r square is equal to, what is the area that told? It is 49 pi. With this, I find out what is the radius of that circle first. When the area is 49 pi, the radius of the circle was 7 centimeters. This is 7 centimeters. And the area of circle was 49 pi. And when it is spreading at some rate, okay, the area reached is 49 pi, they told. So, I make use of the formula for circle as A is pi r square. Differentiate with respect to t. 2 r square derivative is 2r, pi as it is into dr upon dt. dA by dt, they told it as 36. Then already we have solved what is r. The value of radius of that circle was 7 because when the circle is 36 pi, then its radius was 7 centimeters. Just over here calculated. Then dr by dt I want means I will take these constants to the other side, simplify, and it is 9 by 11. Radius per second means I will take the unit as centimeters per second. I hope you have understood. I consider the Another example. A stone is dropped into a quiet lake and waves move in a circular form at the speed of 5 centimeters per second. A stone is dropped into a quiet lake means the waves will be formed like this. Okay, and the waves are moving in a circular motion at the speed of means they are stretching at the speed of 5 centimeters per second. How fast is the area enclosed increasing when the radius of the circular wave is 8 centimeters? It starts from 8 centimeters and going on increasing continuously. First, I write the given things. Let R be the radius and A be the area of the circular wave. What are given things? Its radius is increasing at the rate of 5 centimeters per second. 5 centimeters per second. 5 centimeters per second. How fast is the area increasing? Again, I make use of the formula for A is equal to pi r square. Differentiate with respect to t. We get dA by dt is 2 pi r into dr upon dt. Okay, r is 8, dr upon dt is 5. So we get it as 80 pi square centimeters per second. You have one more example. I think I will give you it as a homework. You can try. Okay. Now, I'll consider one more last example of this video. The radius of a circle is increasing at the rate of 0.7 centimeters per second. What is the rate of increase of its circumference, they asked. So far we have seen about the area. Now we have the circumference. Circumference of a circle is given by the formula 2 pi r, isn't it? And the radius of a circle is increasing at the rate of means radius is increasing at the rate of means dr upon dt is given. What is dr upon dt? It is 0.7 centimeters per second. So with this data, we can find out the d by dt of circumference. So for that, I make dr by dt is 0.7. Circumference of a circle is 2 pi r. I will differentiate this equation with respect to t. D by dt of 2 pi r. Then 2 pi dr upon dt. The radius is increasing at the rate of 0.7 they told. So dr upon dt is 0.7. I take 2 as it is 1.4 pi. Since it is circumference, I write it as just centimeters per second. If it was area, I used to use the unit square centimeters. Now, last example. The length x of a rectangle is decreasing at the rate of 5 centimeters per minute and the width is increasing at the rate of 4 centimeters per minute. Here you can take, you can do it as an experiment. You can take just a flexible cardboard sheet, the rectangular cardboard sheet, cardboard paper you can take, thick paper which is flexible, and when you decrease the, suppose this x is the length of this rectangle and y is the width of this rectangle, the length x of it is decreasing means when it is decreasing like this, then when it is decreasing at that time what happens, the width of this will be increasing. Therefore, they told the length x of a rectangle is decreasing at the rate of 5 centimeters per minute and width is increasing at the rate of 4 centimeters per minute. When x is 8 centimeters and y is 6 centimeters, that is when it was say about 8 centimeters and when it was 6 centimeters, okay, they have reduced the length. At the same time, it moves like this. Okay, you can do the experiment with a sheet of paper. When you reduce the length, width-wise it will be decreasing because you are not cutting that piece of paper. Okay. Now, we have to find out the rate of change of its perimeter and the rate of change of its area of triangle. Now, let x be the edge of the rectangle or the length of the rectangle and y be the width of the rectangle. It is decreasing means I have to take negative sign. Dx upon dt is minus 5 centimeters per minute. Okay. Then width is increasing means I will take it as plus 4 only. Keep it as it is. Now I will take these two examples one by one. First one, the perimeter of a rectangle. How do you find out the perimeter? Length plus breadth plus length plus breadth. Like that. 2 into L plus B. Now Length is I have denoted as x and breadth I have denoted as y, means I will differentiate the perimeter with respect to time on both sides. dp by dt is 2 is kept as it is. This is x plus y, means when I differentiate it becomes dx upon dt plus dy upon dt. We know the length is decreasing at the rate of means minus 5 and y is increasing at the rate of means it is plus 4. Hence I got it as minus 2. Minus 2 means the perimeter is decreasing. The perimeter of that rectangle, perimeter of that rectangle is decreasing at the rate of 2 centimeters per second per minute if it is done in this way. Now, similarly, B question. The area of a rectangle. Area of a rectangle is given by length into breadth. Length is x and breadth is y. Differentiate with respect to t. X into y means derivative x and y both are functions of t here. So x into dy upon dt plus y into dx upon dt. X 8 into minus 5 plus 6 into 4, it is 16. With this, we continue in the next.